In mathematics, a function is a relation between sets that associate to every element of a first set exactly one element of the second set. Typical examples are functions from integers to integers or from the real numbers to real numbers. A function is a process or a relation that associates each element x of a set X, the domain of the function, to a single element y of another set Y, possibly the same set, the codomain of the function. If the function is called f, this relation is denoted y equal to fx, which is spoken aloud as f of x. The element x is the argument or the input of the function, and y is the value of the function, the output or the image of x by f. The symbol that is used for representing the input is the variable of the function. One often says that f is a function of a variable x. Other than in mathematics, functions are widely used in the areas of engineering, design, forestry, electronics, and in the area of science, which is healthcare.
A quadratic function is one of the forms of function of s equal to as squared plus bs plus c, where a and b and c are constant. The graph of a quadratic function is a curve called a parabola. Parabola may open upward or downward and vary in width or steepness. They all have the same basic U-shape.
Polynomial can be expressed in terms that only have positive integer exponent and the operation of addition, subtraction, and multiplication. In other words, it must be possible to write the expression without division. For example, x squared plus 2x plus 5 is a polynomial because all of the variables have integer exponents that are positive, while 5x power negative 2 plus 1 not a polynomial because a term has a negative exponent. Polynomial equation is simply a polynomial that has been set equal to 0 in an equation.
Polynomial also used to find x and y intercept, the open interval where the function is decreased or increased, concave up or down. We can determine stationary points and inflection points. We differentiate the polynomial equation and determine whether it is local maximum or minimum, so that we can sketch a graph by using those results we have determined.
Polynomial functions are used to describe curves of various types, so it can apply in real life to graph curves. For our group, we use healthcare problem as example by using polynomial function. The problem is the weight W in pounds of a patient during a 7-week illness is modeled by the cubic equation, which is Wn equal to 0.1 n cubed minus 0.6 n squared plus 110, where n is equal to the number of weeks since the patient became ill. To find the stationary points, we use the first derivative test for the function w and let it be 0. After get the values of n, we substitute the values into the function w and will get two stationary points, which is 0, 1, 1, 0 and 4, 1, 0, 6.8. From the solution, we conclude that the function w is increasing on the interval from negative infinity to 0 and the interval from 4 to positive infinity, while the function w is decreasing on the interval from 0 to 4. We use second derivative test from function w to find the inflection point and the convexity and let it be 0 to find the values of n. After that, substitute the value of n into the function w to get the inflection point, which is 108.4. For concavity, we can conclude that function w is concave down on the interval from negative infinity to 2, while the function w is concave up on the interval from 2 to positive infinity.
To find the local extreme point, we used to substitute the stationary point, which is n equal to 0 and n equal to 4 into the second derivation of function w. We will know that there is relative maximum at x equal to 0 and for minimum is at x equal to 4. For y-intercept, we let n equal to 0 and substitute it to function w. We will get y-intercept is at 0, 110. After that, let function w equal to 0 to find the x-intercept. There is no x-intercept in this graph since negative number is rejected in human weight. In conclusion, the graph of function w is shown.